Hi, I've just been asked to go through how to do this question. So we've got a 5 gram sample of charcoal, and charcoal obviously used to be wood. It's got an activity of 7.5 becquerels, that's 7.5 decays per second. It tells us that a living sample of wood's got an activity of 23,000 becquerel per kilogram. Calculate the age of the wood. Right, well the way we're going to do that is we're going to look at the activity of the wood now, which we know. We're going to look at what the original activity of the wood would be, and we use this equation here. So a couple of things we need to find before we use this equation. First thing is the decay constant. Now to find the decay constant you need the half-life, and this question would give you the half-life. It hasn't given you the information you need there for the half-life, but the half-life for the carbon decay is 5,730 years. So to find a decay constant, we're going to do log 2 divided by 5,730 years, because that is the half-life for carbon-14. You don't need to remember it for the exam, but they would give it to you, and it's the same in every question. And if you have a look at that, it turns out to be 1.20968, and it keeps on going. So I'm going to put that calculator in my calculator, and it's times 10 to the minus 4, and that's per year. Because we put the half-life in years, the decay constant comes out as per year. So we've got that bit. Now we know what the activity is now. The only thing that we've got to calculate is the activity at the start. It's given us that it's this many becquerels per kilogram, but to be able to compare it, we need to know how many becquerels per 5 grams. So if I wanted to know how many becquerels per gram, I could do 2,300, and I could divide it by 1,000, because obviously there's 1,000 grams in a kilogram. So that would be the activity for 1 gram. I'm going to multiply it by 5 to find the activity in 5 grams, and that comes out to be 11.5 becquerels. Okay, so you could have gone the other way around and worked out, well, if the activity of the 5 gram is that, what would the activity of 1 kilogram be? But because they're different masses, you've got to get two numbers that you can compare for the same mass. Right, so we're going to use this equation. I'm going to just rearrange it. A over A0 equals e to the minus lambda t. And I'll put the logs in now so you can just double check you know where I've gone with that. Log A over A0 is equal to log e to the minus lambda t, just becomes minus lambda t. So now we put in our numbers. So we've got our activity. I'm using the 7.5 becquerels, it tells me in the question. The original activity, I'm using that 11.5 that I found from calculating the comparative activity if the wood was a living sample. And I'm putting that equal to minus, well, I've got my decay constant here that I've kept in my calculator. I'll just put 1.2 times 10 to the minus 4, but I've used the whole number. And then that's multiplied by t. So all you've got to do is go from that last bit there, rearrange and find t, and it should come out. Hope that helps.